Hello and welcome friends. In this new video we find the divided differences when the arguments are equal to some value. Friend, we have seen the how to find the first divided differences when we have two values x0 and x1. Then the divided difference of this x0 and x1 is nothing but f of x0 minus f of x1 divided by x0 minus x1. But when these two values are equal, sometimes it happens that the two values are equal, that is x1 is also equal to x0, and when these two values are equal, this x0 minus x0 will be 0, and this will be 0 minus 0, and that will be meaningless, or we get an indeterminate forms. So how to find the divided difference of this type of arguments? It is the questions. So here the when two values are equal, f of x0 comma x0, we write it as limit epsilon tends to 0 f of x0 comma x0 plus epsilon. And this is the divided difference of these two different points. Then we have limit epsilon tends to 0 f of x0 plus epsilon minus f of x0 divided by x0 plus epsilon minus x0. x0 get cancel, and limit epsilon tends to 0 f of x0 plus epsilon minus f of x0 divided by epsilon, and this is nothing but the derivative at the point x0. So when the two divided differences, two entries or two arguments of the uh, uh, x are when two values of x are equal, then the divided difference is nothing but the derivative. Now suppose three values. Now let us find when the three values of arguments are equal, then f of x0 comma x0 comma x0, we differentiate this, or we distinguish this by writing epsilon and epsilon dash, and we therefore write it as x0 plus epsilon and x0 plus epsilon dash equal to limit epsilon tends to 0, epsilon dash tends to 0, f of x0 comma x0 plus epsilon minus f of x0 plus epsilon comma x0 plus epsilon dash divided by x0 minus epsilon dash. Okay, so this is limit epsilon dash tends to 0, epsilon dash tends to 0, and minus 1 divided by epsilon into, friend, we know that the difference of these two here, here we have calculated the difference of these two is nothing but the f dash of x0 and minus f of x0 plus epsilon comma x0 plus epsilon dash. Now apply the limit epsilon tends to 0, so limit epsilon dash tends to 0, f dash of x0 minus minus f of x0 comma x0 plus epsilon dash divided by this epsilon dash with minus sign. Now this is equal to limit epsilon dash tends to 0, f dash of x0 minus f of x0 minus f of x0 plus epsilon dash, so we consider this as a this a first quantity. Okay, so this is equal to f of x0 plus epsilon dash minus f of x0 divided by x0 plus epsilon dash minus x0 whole divided by this minus epsilon dash. So x0 get cancelled and we get here epsilon dash. So limit epsilon dash tends to 0, and here let us cross multiply this epsilon dash into f dash of x0 minus this f of x0 plus epsilon dash, and this minus this will be plus plus f of x0 divided by this epsilon and this epsilon minus epsilon dash square. Now whenever we apply the limit epsilon dash tends to 0, so epsilon dash tends to 0, 0 f of x0 plus f of x0 minus plus will be 0 and 0. Again we have indeterminate forms. So friend, we apply the L hospital rule. That means the derivative of the numerator and denominator separately. So by L hospital rule, this is equal to limit epsilon dash tends to 0. Epsilon dash, derivative of epsilon dash is 1, so we get f dash of x0 minus, here is epsilon dash, so f of x0, f dash of x0 plus epsilon dash, and this is constant term, derivative of constant is 0 divided by minus derivative of epsilon dash is 2 into epsilon dash, right? Now apply limit. If we apply limit here, this will be f dash of x0, f dash of x0, f dash of x0 minus 0 and divided by 0. Again we get indeterminate form. So again we apply the L hospital rule. So lambda epsilon dash tends to 0. F dash of x0 is constant, so minus f double dash of x0 plus epsilon dash divided by minus 2 into 1. Okay, right? So minus will be plus, and now this is free from indeterminate from, and let us take the limit. So we get this third derivative, third divided differences equal to 1 divided by 2 factorial into f double dash at x0. So the first divided differences is f dash of second 0. Second divided differences is 1 divided by 2 factorial into f double dash of 0. Similarly, the third divided differences will be 1 divided by 3 factorial f triple dash at x0. Hence, by continuing in this manner, if there are r plus 1 equal values, how many? R plus 1 equal values of x0, then f of x0 comma x0 x0, how many times? R plus 1 times, r plus 1 times, then this will be r factorial into rth derivative at x0 of the function. So in this manner we find the divided difference of the function when the arguments are coincide or arguments are equals. Thank you friend, thank you for watching this video.